So there are several public lectures that I have given, which for some reason were not recorded, or even if they were recorded, they were not made available publicly. So all those slides, the presentation decks that I used are sitting on my laptop, and I thought it was time to bring them to good use. So I decided to redo these lectures in the form of YouTube videos. If I were to make one single video for each lecture, the video would be very long. It can go as high as 40 to 45 minutes. So I decided that I would put strategic breakpoints and release these lectures in parts. So this is the first part of the first such video that I'll be recording. So the first talk or lecture that I have chosen for today is something called On Measuring Lengths. It was given in the month of September, year 2016, to an auditorium full of enthusiastic kids, 9th and 10th class students. And I had only 1 week to do the entire research behind this lecture and give it as a presentation. So this is what I will be covering. So this is the first part of On Measuring Lengths. I hope you enjoy it. So let's begin. All right. So let's ask a simple question. How do we measure lengths? So if I give you a line on a piece of paper and I ask you, how will you measure the length? So it's quite simple. Most of us know how to do it. We will take a scale and we will put the zero of the scale on one end of the line, and the number on the other end of the line is what our length is. So assuming that this is a centimeter scale, then the answer here is 4.5 centimeters. But let's ask some questions regarding this. First question, if I took the same piece of paper to some country in Europe, for example, and I asked somebody there, hey, what is the length of this line in centimeters? What do you think the answer will be? I'm sure you'll all agree that they'll give the same answer, which is 4.5 centimeters. That raises another interesting question. In a country far, far away, with completely different manufacturers, different governments, very different cultures and customs, how is this possible? How is it that the instrument they are manufacturing is also going to give you the same answer as an instrument in your own country? Now, if you want a full understanding of this answer, you need to understand many subjects. You need basic mathematics because numbers are involved. You need trigonometry because there'll be a slide that comes later where we will actually use trigonometry. We will need thermal physics because the temperatures in each country are different and these temperatures have an effect on the material which is used to build the instrument. So you need to understand thermal physics. We need some understanding of political history because a lot of this is actually motivated by historical events. We need understanding of geodesy, which is basically a science dealing with measurements of distances. We need metallurgy because metallurgy essentially tells you what the properties of metals are, and that will also become relevant later. We need the understanding of astronomy. Why? Again, hold your horses, we will get there. We will need understanding of electromagnetic wave theory, optics, and spectroscopy. Okay, so for now, let's ask the very basic question, what is a measurement? So there are two things that you require for measurements. First is a number, right? The number could be an integer, or it could be a floating point number or a decimal number. And you need a unit. So you can have a variety of units, like centimeters and inches are used to measure distances or lengths, and kilogram is used to measure mass, liter is used to measure volume, and Celsius is used to measure temperature. So these are all units that you need to complete a measurement along with a number. Okay, so let's focus on measurements of lengths, not anything else for now. So I give you this line, and let's say I give you a pen. Suppose I place this pen at the beginning of the line. It is clear that the pen is shorter than the line, so I cannot say that they are equally lengthy. But if I keep two pens side by side, or one behind the other rather, then you will agree that these two pens together are equal to how long the line is, right? So we can say that the length is 2 pence. That is how units work. We will use a number to tell how many of those reference units are needed to define the current measurement. So in this case, we need 2 pence to define the measurement of this line. So we say that the length of the line is 2 pence. In fact, in the old days, that is how measurements were done. The famous unit, which we call inch now, originally was defined as 3 seeds of barley. So you take 3 seeds of barley, put them one behind the other, and the total length of these 3 seeds of barley was what was defined as an inch. You may have heard of a unit called yard. Even though MK's system of units is the recommended system, for some reason we are obsessed with feet, inches and yards. So you might be surprised to know that a yard is defined in this manner. So it is the distance between the thumb and the nose of King Henry I, assuming he has stretched out his hand. So King Henry I would stretch out his hand like this, and the distance between the nose and the thumb was defined as a yard. So that's how yard is defined. Now there are clear problems with such units. First of all, the reference itself can change very easily. Take barley seeds, for example. Back in the days, maybe all barley seeds were very similar to each other, but one can imagine that something might happen, a new variety of barley might be produced, a genetic variation, and those seeds have different lengths. Or maybe the seeds get wet or roasted or dried, or something happens to the seeds and their length changes. The other important issue is, how do you verify? Let's say that a guy decides to make a scale which he says is a perfect yard. Somebody says, I don't believe you. I don't think this is a yard. So what do? You have to go to King Henry I, and you will have to say, hey, stretch your hand again. And then you will have to see if the yard stick is correct or not. And clearly you don't want to do that. So this is the problem when you use arbitrary units. The other important problem is that even if we agree to use the same units in different places, their meaning can be deliberately changed. So sometimes it is a miscommunication that happens. So somebody tries to explain what a yard is, the other person misunderstands, and that is how the meaning of a yard can change. And sometimes it can be motivated by profit or politics. Let me give you a simple example of that. So let's say that somebody has defined a quantity, we'll call it whatever. Some whatever of rice costs 10 gold coins. Now in the place A, this is the amount of rice, let's assume, that you can buy using 10 gold coins. Now this merchant goes to a place B and he realizes that nobody in that place knows exactly whatever of rice means. They only know that whatever of rice can be bought at 10 gold coins price, but they do not know what exactly whatever is. So deliberately, this merchant will sell a lesser quantity of rice and redefine it as whatever. So now place A assumes that the left side quantity of rice is whatever, and the place B assumes that it is the right side quantity, which is whatever. And this was a major problem that was noticed by many people, and it was the around the French Revolution that the French Academy of Sciences felt that enough of these arbitrary units based on kings and seeds and so on, let us try to find something within nature in order to define the units. So what exactly that was, that will come in the next part, the next video in this series. Just to summarize what we have learned, we've seen that we need a reference unit in order to do any measurement. And in the early days, it was seeds of barley, the distance between the nose and the thumb of King Henry I. And we have seen what the problems are with these units. And we have also seen that there is a need to come up with units that are more inspired by something that is constant in nature. And that is what the French Academy of Sciences proposed. How exactly did they go ahead with this? We will soon find out. See you in the next video.